So in this problem, we're told that we're going to be doing something with the Archimedes Principle, which has to do with that old Greek story about Archimedes putting the king's crown in the bathtub with him to measure the volume of the crown by seeing how much the water in the bathtub rose. What we're doing here is we're submerging an object, right? We don't know what this object is, but we're just submerging an object in something called a right circular cylindrical tank. Boy, that is a mouthful. Let's just draw a picture of what that means. A right circular cylindrical tank means this is a volume that is just what everybody would normally think of as a cylinder. Okay? The sides of the cylinder form a right angle, and the bottom of the cylinder, right here, is a circle. So it just means a cylinder that is nice and straight and upright, and maybe not like I drew here because I'm a terrible artist, but you have a circular base and you have straight walls that go up. Okay, so that's my picture. And I'm told that the diameter of this tank is 18 centimeters. That's this right here, 18 centimeters. And it's filled with water up to a depth of 10 centimeters. Okay, so let's just call this 10 centimeters. It's how high the water goes. And I dunk my object in there, and it sinks to the bottom, and the water rises by 0.5 centimeters. So what's the volume of the object rounded to the nearest cubic centimeter? What you might do by accident is calculate the volume of this picture that I drew here. That would not be correct, because what we're not doing is measuring the water volume. We're measuring the change in water volume. Okay, the change in water volume has to do with this 0.5 centimeters right here. So to calculate the change in water volume, I take the area of the circle, right? And if remember, well, let's actually talk about the volume of a cylindrical volume, and that's going to be pi r squared times h. That's something you should know. So if I take pi r squared times h, what's the h that I'm interested in? It's the change in volume. So delta V, that's the change in water volume, equals pi r squared times delta h, the change in the height when you dunk this object into the tank. So that's going to be equal to pi times 9 squared times 0.5, okay, which is going to be, well, this is why we have calculators. 3.14159, that's pi. Most calculators have a pi button on them too, you can use. Times 9 squared times 0.5 equals 127.2 with some decimals, and they want us to round it to the nearest cubic centimeter, so let's just call this 127 cubic centimeters. The key here is that we are measuring the change in water level. Okay, that's the water level displaced.